back. So now we look at examples from economics. Suppose Cx is the total cost that a company incurs in producing X units of a certain commodity. The function C is called cost function. If the number of items produced is increased from x1 to x2, then the additional cost is delta C, C of x2 minus C. So as always, change in cost from x1 to x2, C of x2 minus C of x1. So what is the average rate of change? It is delta C over delta x. Okay, again this is slope of the secant. Now what is the marginal cost? Marginal cost is instantaneous cost. Okay, so when delta x goes to 0, the instantaneous rate of change of cost with respect to the number of items produced. Okay, that's called marginal cost. So marginal cost is the instantaneous rate of change. So that's limit delta x greater than 0, tending to 0, delta C over delta x. So that's the derivative. So that is the marginal cost. Remember that. Since x often takes only integer values, it may not literally make sense, right? X is number of items produced, but this limit does not really make sense unless the cost function is replaced by something smooth approximating function. All right. Now taking delta x equals 1 and n large enough, so C prime n is approximately same as C of n plus 1 minus C of n. What that means is, suppose you're manufacturing chairs, right? When you have produced, say, 5,000 chairs, one more chair so if delta x is 1, you're looking at 5,001st chair basically. So when the number of chairs is so large, one more is not that much large. In other words, the derivative is very close to Cn plus 1 minus Cn. That is the one additional chair you're going to manufacture after producing n units. So the marginal cost is approximately equal to the cost of producing one more unit, that is the n plus first unit. So it is often appropriate to represent a total cost function by a polynomial. A represents overhead cost, for example, rent, heat, maintenance, and the other terms represent cost of, say, raw materials, labor, and so on. You see, if you have 10 workers, then B times 10 is probably the cost coming from the workers alone. A, that is, say, the rent doesn't change as number of workers changes, and so on and so forth, right? Likewise, if you have other things like raw materials, maybe materials squared. Not only are you purchasing materials, you're having to transport them, store them, so on. So it's more complicated, right? So depending on different parameter, you will have different powers. Anyhow, so the cost of raw materials may be proportional to X. Labor costs might depend partly on higher powers of X, and so on and so forth. Okay. This is just argument, right? So for example, your cost function could be 10,000 plus 5x plus 0.01 x squared. What is the marginal cost? Remember, marginal cost is the instantaneous rate of change. So that is the derivative. So you take the derivative of this. So marginal cost at production level of 500 items is, so at 500 items, you will calculate this. What does this mean? This means for the cost of producing the 501st item is around $15. Okay. Now the actual cost of producing the 501st item is C501 minus C500. So look, this is very close to the derivative at 500. So derivative at a large enough number actually gives you an approximation to the actual cost of producing that n plus first item. Okay. Other sciences. In other sciences, rates of change occur in all the sciences. Geologists interested in knowing rate at which an intruded body of molten rock cools by conduction of heat. Okay. An engineer wants to know the rate at which water flows. An urban geographer is interested in the rate of change of population density. Meteorologist is concerned with the rate of change of atmospheric pressure. So there are many, in fact, calculus is used in almost every science, right? Single idea, many interpretations. Velocity, density, current, power, and temperature gradient in physics, rate of reaction compressibility in chemistry, rate of growth and blood velocity gradient in biology, marginal cost and marginal profit in economics, rate of heat flow in geology, rate of improvement of performance in psychology, rate of spread of a rumor in sociology. These are all special cases of a single mathematical concept, the derivative. So, a single abstract mathematical concept can have different interpretations. When we develop the properties of the mathematical concept once and for all, we can then turn around and apply these results. Okay. So this is much more efficient than developing properties of special concepts in each separate science. All right. So this is why the basic calculus is more or less requirement for any major, no matter which major you go to. For any basic study, serious study, for any research project, in any branch of study, you will need calculus. Okay, so next video will cover problems from web work. Until then.